class, what's a good balance between usability and...
Don't answer. Ask Mark. It would be inappropriate for me to answer that. It would be inappropriate for me to show you how to run a regression on Excel. Now you just click OK. Bottom line is sometimes, you know, if you want your constant to be 0, if you want to intercept at 0, you know it has to be something you need to fit in that space. You don't really want to place too many constraints though on a model. That's the beauty of the regression analysis. You don't want to do that. But sometimes you might want to do that. You might want to have some sort of confidence level, do whatever you want, put in a new worksheet, new range, calculate the residuals. Oftentimes comes in handy. You click on the residuals plot, whatever you want to do it. Click on OK, and boom, there's your output, which should look an awful lot like my CTI, I hope. Yep, exactly the same. That's what that is. Sorry to do that. Sometimes you have to download the package, the statistical package, into Excel. That's the only thing I'll touch. That's the most difficult part, which is not difficult at all. Very, very easy to work with. We have temperature on the left-hand side of the equation, GDP on the right-hand side of the equation. We understand that real GDP is in billions. Other things to kind of take note of. We also understand that GDP is, in all probability, real GDP, because it explicitly states a base year. So if it's a base year, then it's probably adjusted for inflation. Given this information, we have these results. Very quickly, what R squared, adjusted R squared, which will be explained in better detail here, but just very roughly speaking, what we're looking at here, and R squared tells you how much is being explained by the independent variables. So it will never be 1, because you are never 100% confident that it's explaining everything. So it ranges from 0 to 0.9999. Adjusted R squared will never be higher than R squared. Adjusted R squared takes the R squared and it penalizes for insignificant variables. So that will always be lower than your R squared. So the important things to take note of is your R squared. Sometimes adjusted R squared, yes?
Is adjusted R squared the same as R bar squared?
Yeah, I think it is.
Did you jump ahead to 7A? Or do you mean to be?
No. Oh, gosh. I'm sorry.
You said adjusted R squared penalizes for insignificant variables?
Right.
What does that mean, penalizes exactly?
Means that if I tossed in here, along with temperature and GDP, I tossed in box office sales, which should be, I don't know, maybe that actually would be correlated to something. Something that would be completely non-correlated. Either of these. It would end up being an insignificant variable. So what happens here is that along with R squared and adjusted R squared, we have a lot of information here, which we won't bother with right now. We have our intercept and our X variable coefficients. Our coefficient, this is probably the most important thing, important number in all of this. If I had to say the important information in all of this, it would be here, your R squared, your adjusted R squared, your intercept, your X variable, which is extremely important, and always your t-stats. Those are the very important things to take note of. If you feel very comfortable and confident with those things, then I'd say move on to the next one. Understand what p-value means, understand what standard error, which is directly correlated to coefficient and t-stats, just 1 divided by 1. Those are the important things. Model comes out, what's the R squared look like? How strong is it? I got a big R squared, it's really good. Look at how high that is, right? Adjusted R squared, really not penalized very much. All my variables are relatively significant. T-stats tell you how significant these are. So you have your variables, your t-stats are going to tell you how significant they are. That is a function of your degrees of freedom, which is a function of your observations and the number of variables that you have. All of this will be explained the detail of what I'm sure later on. Just give me a very brief outline for 5 minutes or so. Then the coefficients are the most important things. Coefficients are the slopes of these lines that we drew. Those are the things that we really are doing all this with. We want to understand what these slopes are. We want to understand how much one variable is affecting the other one. Now, obviously, we want to make sure that it's statistically significant, R squared is higher and all that, but it's very important that we understand how much this one is affecting the other. So, can somebody explain to me what is happening here? As he asked for it in 6C.
Basically, if GDP went down to 0, the average yearly temperature would drop about 0.26 degrees, and I guess for every unit increase in GDP, the temperature would increase by 7.43 to the negative fifth column.
Okay, that's not a bad one. So what he's saying is here's your intercept. If GDP was 0, we were drawing this, and in this case, our left-hand side of the equation is temperature, and over here is GDP, and over here is temp. What he's saying is that this intercept, when GDP would end up being at 0, would be right here in the negative region, and our x variable is a positive slope, and the slope of it is our beta 1, in this case, equal to 7.43, 7.43 like that. Make sense? It's a little bit more sense than this, all that stuff. It's a little confusing. That's what we make it a little bit more